All right, guys, we are going to try this morning. For some odd reason, my document camera is not wanting to focus, so we're going to make do. But today we're going to talk about the trig functions, the 6 trig functions, and you have done these prior, mainly in Math 2. You do some of them in Math 3, but mainly in Math 2. So basically your 6 trig functions are as follows. All right, and yesterday we talked about sine and cosine. Sine being y over r and cosine being x over r. All right, so then today we're going to add in there tangent, which is going to be y over x, and then cosecant, which is going to be r over y, secant, which is going to be r over x, and cotangent, which is going to be x over y. Okay, a couple of things you do need to know, and I'm going to put under here how to say these just in case you don't remember, but this is cosecant, and this is secant, and this is cotangent, and obviously cotangent, since we didn't do this one yesterday, goes along with tangent. All right, and up here for sine and cosine, you can have any value for your denominator. R, because for r being a radius, if r doesn't exist, there's not a circle. So there's no stipulation here on your denominator. However, on tangent, cosecant, secant, and cotangent, of course, there is the stipulation here that like x can't equal 0, y can't equal 0, x can't equal 0, and y can't equal 0. That's just because then we would have a 0 in our denominator and we would be undefined. All right, so a couple things you need to notice about up here, and that's why I write them the way I write them. If you notice that sine and cosecant are across from each other, cosine and secant are across from each other, and tangent and cotangent are across from each other, and that is intentional. And whenever we do our problems down here, it will be intentional there as well, just because it makes it a little easier to see a very important relationship. Okay, so first thing I want you to see is that cosecant is 1 over sine. Okay, so they are reciprocals of each other. And the same thing goes for secant. Secant is 1 over cosine. Cotangent would be 1 over tangent. And then there is one more that we want to talk about. One more we want to talk about briefly, because we will use it several times later on into this class or even calculus, is that tangent is the same thing as sine over cosine. Okay, and we talked yesterday about tangent being your y value over your x value, and that's the same thing. So if you look back up here, remember sine is our y, cosine is our x, and we talked about that in class yesterday. All right, so example number 1, find the value of the 6 trig functions for theta in standard position if a point with coordinates -15, 20 lies on the terminal ray. All right, so the first thing I'm going to do is I'm going to draw me a figure. Okay, the point -15, 20. So if I do -15, that's going to go left 15, and I'm going to go up 20. Okay, so here's my ray. Okay, so again, I've got a right triangle. All right, I've got my x, I've got my y, but I don't have my r. Okay, and just so you know, they did tell you in the problem the ordered pair. It doesn't tell you what quadrant, so you've got to have some knowledge that this is quadrant 2. And that's where I drew my triangle, my reference triangle. All right, so we are going to find our r here, but before I do that, I'm going to go over here and I'm going to go ahead and write my 6 trig functions that I'm going to calculate. Sine, cosine, tangent, cosecant, secant, and cotangent. All right, so as discussed yesterday, in order to find the missing side of a right triangle, we do use Pythagorean theorem. So in this case, we're going to use r squared equals x squared plus y squared. Most of you learned it a squared plus b squared equals c squared, or c squared equals a squared plus b squared. That's fine, but we're just representing things in terms of x and y for our reference triangle, like on the unit circle on our coordinate plane. But we'll talk in a little bit how that also relates to just in general. All right, so here's our theta right here. So we've got r squared equals x is going to be negative 15 squared and 20 squared. And then we're just going to work from here. And then when we take the square root, r is going to equal 25. Now remember, r is your hypotenuse, so this is always going to be positive. And now, from here, okay, we are going to fill in everything that we need to know. So look back up at the top, and we're just going to fill in what we have. Sine is y over r. Y is going to be 20. R is 25. And then we're going to simplify that down to 4 over 5. Cosine is x over r. So that's negative 15 over 20. Simplifies down to negative 3 over 5. Tangent is y over x. So y is 20. X is negative 15, and that simplifies down to negative 4 over 3. Once you get these, getting their reciprocals is easy because all we're going to do is go in here and flip what we've got. So 4 over 5 is going to become 5 over 4. Negative 3 over 5 is going to become negative 5 over 3. And remember, you can put that negative with the top or the bottom. I will always put my negative on the top. But the fraction itself is negative. Don't put it on both because that's a positive, but you can put it top or bottom. And then negative 4 over 3 is going to become negative 3 over 4. All right. Sorry. Okay, so going to the last page, actually. Okay, last 3 examples here. All right, so we're going to find the 6 functions of angle E. I have no idea why that E is cut off. That's angle E, okay? All right, so angle E is here. Okay, so this is our theta over here. All right, and now we've already got our 2 legs. Now notice we're not on the coordinate plane here, okay? So to say this is x and y, we can do that. It doesn't matter what variables you use for that. However, you're still missing the third side. So we're going to use our knowledge of Pythagorean theorem, again, to find this third side. Okay, so you can do, like I said, you can use whatever variables you want to use. I'm just going to keep it with r, and I'm going to keep it with x. And it doesn't matter which one's my x and which one's my y. So that's 49 plus 9. So r is going to be, r squared is going to be 58. So r is going to equal the square root of 58. Okay, so we're going to put that up here. All right, and here we go. Let's get our 6 trig functions. Sine, cosine, tangent, cosecant, secant, and cotangent. All right, and now this time there is an extra step. Obviously, that's why we're going to do this type of problem. Okay, because whenever I do the R has a radical in it. Remember, we can't leave a radical in the denominator. Now, one thing you can do here that you learned a couple years ago is SOHCAHTOA. Okay, you can use that. Instead of having to use X and Y and R, you can use, so here's our angle. So remember, sine is opposite over hypotenuse. So if this is our angle, this is our opposite, this is our hypotenuse, and this is our adjacent. So you can still use that same thing you already know and are already familiar with. All right, you could put theta here, or you could put E since you're actually looking for the angle E. You could put E there as well. Either will work. All right, so sine, opposite over hypotenuse. Okay, and we're going to rationalize that with the fancy one. So remember, we multiply the top and bottom by the square root of 58. So it's going to be 3 square root of 58 over 58. All right, cosine is adjacent, which is 7 over the square root of 58. And that's going to be 7 square root of 58 over 58. Okay, now when I get over here, we'll talk about what's easier from here to here. All right, and then tangent is going to be opposite over hypotenuse. Opposite over adjacent, sorry. So that is 3 over 7. No simplifying to do there. All right, so whenever I go to do my flip here, if I flip my final answer from sine, I'm going to have a radical back in the denominator. And I'm going to have to do everything over again. So just flip your original, and that puts the radical on the top, and we're good. And there we go. And notice, if we were on the coordinate plane, this would appear, okay, to be in quadrant 2. But we're not, so all of our links are positive, therefore everything over here is positive. All right, example number 3. In which quadrants do sine theta and tangent theta have opposite signs? All right, well, let's talk about that. There is a way to remember this that I was taught a long time ago. Okay, it's called all students take calculus. And it literally tells you what's positive. So in the first quadrant, everything is positive. Sine, cosine, tangent, cosine, cosecant, secant, cotangent, all of those, okay? In the second quadrant, sine is positive, which also means that cosecant would be positive. In the third quadrant, tangent is positive, which would also mean cotangent is positive. And in the fourth quadrant, cosine is positive, which would also mean that secant is positive. So in other words, if we want to know in which quadrant sine and tangent have opposite signs, well, here they're both positive. Here, tangent is positive and everything else is negative. So we do know that 3 is an answer. And here, sine is positive and everything else is negative. So sine's positive here, tangent's negative. Tangent's positive, sine's negative. So our answer here would be 2 and 3. Okay, the other way that you can do this, y'all, is you can know, like in quadrant 1, we're positive, positive. In quadrant 2, we're negative, positive. We are negative, negative, and we are positive, negative. And remember, sine is your y value, so we're positive, positive, negative, negative. And tangent would be the ratio of the two. So positive over positive, positive over negative, negative over negative, positive, and you could find the ratio there as well. All right, last problem. All right, suppose theta is an angle whose terminal ray lies in quadrant 4. Find the values of the remaining trig functions. If secant is the square root of 29 over 5. Okay, so quadrant 4. So I'm only going to draw quadrant 4 here, y'all. So if we drop our angle, drop our perpendicular. Okay, so secant, remember, is, if you go back to your front page, right, secant is r over x. R over x. So that means our r is the square root of 29. And our x is 5. So now again, we've got to find our missing side. And we're just going to work backwards here. So r squared equals x squared plus y squared. So the square root of 29 squared equals 5 squared plus y squared. So square root of 29 squared is going to give me 29. Okay. And then 5 squared is going to give me 25. So that gives me 4 is y squared, so y is 2. Okay, and it could be plus or minus 2. And because we are in quadrant 4, we know that our y value is going to be negative. So here we go. Sine, cosine, tangent, cosecant, secant, which was already given to us, and cotangent. All right, so sine, y over r. So y is negative 2 over the square root of 29. And rationalize again, so negative 2 square root of 29 over 29. Cosine is 5 over the square root of 29, which is going to be 5 square root of 29 over 29. And then tangent is going to be negative 2 over 5. Tangent's really easy to flip cotangent. It's just going to be negative 5 over 2. Cosecant was given to us, the square root of 29 over 5. And then remember, up here, I'm going to flip it from here. So negative square root of 29 over 2. And that's it. All right. Refer back to this video if you need to. And make sure you get your worksheet done on here.